All right, so we're going to talk about particle motion. Those of you that took AP Physics last year, I realize there may still be some trauma, but you're going to have to take a deep breath. It'll be okay. Don't tune me out because you start hearing words like velocity and acceleration, and it's all going to be okay, all right? So this first page that you have in front of you, a lot of information, okay? So as we talk through this, you might want to make yourself some notes on it because you are probably, until it kind of gets ingrained in your brain, going to need to look back at this to refer to make sure that you're using pieces correctly, okay? So I chose to go ahead and leave it where it's all already written out for you, so it wasn't an issue if you can't read your own handwriting or you didn't write something down right or whatever, but there's tons of information that it looks more overwhelming than it really is. It's really going to be okay. Right? You just got to go into it with deep breath and an open mind here, okay? So particle motion. So if calculus had a parent topic, like the overarching topic, it would likely be kinematics. Oh, no. It's okay. Kylie, take a deep breath. It's the study of the motion of an object. Here's the thing. Had you learned this last year, it probably would have made physics a whole lot better. This is going to teach you the math behind the physics, where in physics you were just told, do this, right? Okay, so specifically, calculus was specifically developed. So calculus was specifically developed to be able to connect the concepts of position, where we are, to velocity, the rate at which our position changes over time, and acceleration, the rate at which our velocity changes over time. Okay? So I know I did a bad job. I pretty much underlined everything, and that doesn't do any good to it, but you know. But where it's so particle motion can also be called PVA, and that's position, velocity, acceleration. That's what PVA is, position, velocity, which is what pretty much all this is about. Okay? All right. So we are going to talk a lot about a particle moving along an axis. So look at this little x and y axis here. Okay? I can have a particle, and we're not really talking about like plotting points. I can have a particle that moves back and forth on the x-axis. It can move left and right. And I can have a particle that moves up and down on the y-axis. All right? So we get to go back and forth on an axis now. Position on the horizontal axis at a time t is x of t. Vertical axis, y of t. Position on some generic line is s of t. Okay, so that's just kind of generically how that works. X is talking about the x-axis, y is talking about the y-axis, s is just some random line. Okay? So velocity at a time, we use v. Okay, so we use a lot of f and g and things like that, but these letters are going to kind of be specific to what we're doing. V of t is velocity, a of t is acceleration. Okay, all that makes sense so far? Okay. So when you hear words like initially, at the initial position, anytime anything's initial, your time is 0. So that's where you start. That's your initial whatever. Okay? At the origin, s of t, which is the position, at the origin, that means your position equals 0. At rest, v of t equals 0. What does v of t represent? Velocity. So this is when velocity equals 0. Okay. All right. So we're going to see how we're going to use all of this. Remember, s is your position, or it could be x or y. So when we analyze our motion, our displacement, so if I start here and I move all the way here and then I move all the way back, my displacement is 0 because I'm right where I started, right? But if I move all the way here and then I moved all the way here, this is my displacement right here. Does that make sense? So it's not about how far I went or even which direction, it's how far am I from my starting position. So that's why you're going to have s of t sub 2 minus s of t sub 1. So you're just, if I want the displacement between t equals 1 and t equals 5, I find s of 5, s of 1, and I subtract them. Okay, it's just you find the two positions and you subtract them. That's your displacement. Okay. Yes, kind of. It's your starting and stop point. Yes, very good way to say it. Okay. So here's some of those little explanations where maybe right now you don't even know what to write on here with little notes, but as you look back at it, you want to be able to find what you need quickly, all right? So it says when displacement is positive, so when displacement, so we're looking at displacement is positive, the final position is right of the original position. So let's think about that. If I start here, and I'm going to move this way, and then I move right here, my displacement is positive. If I start right here, and I move here, and then I come back here, my displacement is negative because I'm at the left of where I started from. I went back farther than I actually was, right? So when displacement is negative, the final is left or below, because I mean it could be right or above, because if we're talking about on the y-axis, then it's up and down and not left and right. Okay, so if displacement is positive, you're to the right. Displacement is negative, you're to the left. Those, I think, logically kind of make sense, I hope. All right, so you look at your velocity. This is why, if you remember when we were graphing last year and we were even just sketching things, and I said sometimes we can't sketch the whole thing. Maybe we don't know where our max and minimum is. Maybe we only care if our function is positive or negative at these. This is one of those things I was talking about. When velocity is positive, the particle is moving right. So when velocity is positive, it's moving right or up. So we can look at a velocity graph and go, oh, look, it's positive. That's all. I don't care what the actual values are, but it's positive, so right then it's moving to the right. When velocity is negative, it's moving to the left or down. Okay, so we've talked about position, and we've talked about velocity. So velocity is like your speed, right? They're related to each other. They're not the exact same thing. But then you also have acceleration. That's a of t. So if your acceleration is positive, then the velocity is increasing. So you can think of when you accelerate in a car, right? Your speed is increasing. If your acceleration is less than 0, or negative, then the velocity is decreasing. So if you think about those things, they do hopefully make some logical sense. So you want to make sure that you're putting them in, in your brain. When you look back at this, you can find what you're looking for. All right, now let's talk about how we find velocity and acceleration. I don't know that you did this. Would you have done this in physics? Because you didn't do derivatives and stuff in physics, did you? Okay. So we have everything on the left is, yeah. Okay, so relationships between position, velocity, and acceleration. So velocity is the derivative of your position. Okay, so s of t, when I take the derivative of that, that gives me v of t. So that's what this says right here. So we're looking at velocity. Velocity is the rate of change of position. It's also the derivative of the position. Okay? Average velocity, anytime you see the average of anything, you're usually finding slope. So you find this average velocity, you're not using the velocity function, it's the change in the position. It's the rate of change of position. Okay? Then we have acceleration. Acceleration is the derivative of velocity, so it's the second derivative of position. This is how these are related. You take the derivative of position, you get velocity. You take the derivative of velocity, you get acceleration. That's how you're going to get those functions. Another way to look at it is so if this was s ds dt, that's the same thing as s prime. So v prime is the same as dv dt, and s double prime is the same as d2s dt. Okay? And then it says acceleration is the rate of change of velocity. So your derivatives are still your rate of change. Right? Velocity is the rate of change of position. Acceleration is the rate of change of velocity. Do you see how those are related? Okay. PVA, and it goes in that order, right? I mean, I know that this is backwards, but you have the position. You take the derivative of position, you get velocity. You take the derivative of velocity, you get acceleration. PVA. Okay. We good so far? I know this is a lot of information, so I'm going through it slowly. That's why we're not going to do a ton of examples today. We're going to do like one, talk about these things, let it kind of sink in your brain a little bit before we do some more, okay? So let's talk about speed, right? Speed is the magnitude of velocity. That means absolute value. Magnitude absolute value. Oh, my pen is still being stupid. Absolute value. So plus and minus don't matter. So your speed is whatever the absolute value of velocity is. If velocity is negative, what does that tell us? Yeah, when velocity is negative, it's moving to the left or down, okay? But so that means like if I'm going a negative 33 miles per hour, that doesn't mean I'm going less than 0, right? That means I'm going to the left, but my speed is 33 miles per hour. Okay, so speed and velocity aren't the exact same thing, but they are very much related. Velocity, you just take the absolute value of it, that's when you get the actual speed. Okay, we okay on all that? All right. Now here's another important thing, and I know that these things definitely come up here, so we got to make sure we type these correctly. If we want to know if our speed is increasing when the velocity and the acceleration are going in the same direction, that means that they are both positive or negative. Same direction means they have the same sign. Positive, positive, negative, negative, because that's the way we're going to look at what's happening there. Speed is decreasing when the velocity and the acceleration are going in opposite directions. So then that means that is when one is positive while the other is negative. Signs are different. So we can put out here same sign. Yeah. Same signs, opposite signs. And we're going to do a sign chart today. Ew, I know. Yeah, I know. When you walked off, I thought she thought I was talking to the other kids, because we have been doing them in pre-cal too, but we're doing one in here today. And this is one of the reasons why we do sign charts. Because again, we don't care about the actual graph, just is it positive or negative. Okay, so then we have distance. So we've talked about displacement, we've talked about speed and versus velocity. So if I want the total distance traveled over time, you must calculate the sum of the absolute values of the displacements between all points where the particle is at rest. When is the particle at rest? When what is 0? Everything. Everything has to be 0. No. Here's at rest is when velocity is 0. Think about when you're driving. You can kind of I'll take it back to like a car. I mean, this is all different types of situations, but you can kind of think of it that way. When I'm pushing on the accelerator and I'm speeding up, I'm accelerating and my velocity is increasing, right? If I am stopped at a stop sign, I am at rest, I'm not going anywhere, and my velocity is 0. Okay, does that make sense? Velocity has to be 0. All right, this is a lot of information, right? But we're going to flip back and look at this as we talk through each question. Put it all together. It won't be that bad. I know it seems a little overwhelming. Okay, so let's look at this first example, which is on the back of this. Not on the very back. And so yes, you're probably going to have to flip back and forth. I apologize. I thought about doing it separately. Actually, I have. No, I want you to flip back and look at yours in case you want to mark on it. Okay, so here's what we have. And I know I'm probably wasting my breath saying this, but always make sure you read the question. Okay, so we have particles x and y. They are moving along the x-axis so that time t is positive is given by this. All right, so I have two particles moving on the x-axis. Notice on that other page, it said x of t was the x-axis, y of t is the y-axis. But this is saying they're both on the x-axis, so just know that they can change the rules on you a little bit. All right, so here's what we want. At t equals 1 is particle y, so we're looking at particle y, moving to the right or to the left. So what do I have to know to decide left or right? If velocity is positive or negative, right? Does that make sense? So that means I'm looking at particle y, that's this right here. I need the velocity of y. So the velocity, I'm going to put a little subscript of y, velocity of y of t, which means I have to do what to this function here? Take the derivative. Okay. So what process am I going to use to take the derivative? Chain rule, right? Because I have a function inside of a function. We agree with that? What? Okay. Do I have to do quotient rule? That's a good question. Because she said that with a question mark. Do I have a variable in the denominator? No, I don't. So this really could be 1/4 times this. So since I don't have a variable, I don't have to. I could, but it would just kind of be a waste of time. Okay? That's a good question. That's a good observation because that's the things you guys have to be thinking about. All right, so I'm going to take, what's the derivative of cosine? Negative sign. So negative sign of the exact same thing you see, pi times t squared over 4. Ugh, my pen's being stupid, so my numbers look weird. Right. Am I done? No, because we said chain rule, right? I have to take the derivative of what's in here. So I take the 2 and multiply it out in front. So this is going to give me 2 pi times t over 4. Could I reduce that? Yes, but I'm just going to kind of wait because I'm going to actually substitute something in, and so I can kind of, that way I'm not rewriting 1,000 times. Okay? Did we do everything we need to do to take the derivative? Yes. Okay, so always double check yourself before you just move on quickly. All right, so we're good. We did our little chain rule. I think we're good. All right, so now what I want, it says that t equals 1, so I need the velocity when t equals 1. So I substitute this in. This is going to give me negative sign. All right, so t squared is 1. And so this is just gives me pi fourths. And then I put 1 in here. So this would be 2, and then this will reduce to 1/2. So it's really just pi over 2. We agree with that? So do I move to the, I'm sorry, do I move to the, can I multiply these two together? No, this is the sign of this. This is one thing here, and this is just a constant, okay? What is the sign of pi fourths? Square root of 2 over 2. So this gives me negative square root of 2 over 2 times pi over 2. Do I need to actually do anything else, or do I have enough information to answer my question? I have enough information, because all I care about is the velocity, if I'm talking left or right, is the velocity positive or negative? So since it is negative, which way is it moving? Left. So we say at t equals 1. And I don't think we have units for, it just says t. It doesn't say if there's seconds or what. Turn that off. Particle. Which particle are we talking about? Y. Particle y is moving to the left, or is moving left. I guess we can cut out some words. Left. Because, why? Okay. Velocity is negative. Yeah. Okay. So are there other ways to word that? Yes. And sometimes when I get halfway through my sentence, I think, oh, I could have said this and it might have been shorter, but I just finished my sentence. But here's some things you got to make sure you say. At what time are we talking about? Which particle? Because there's more than one. So you can't say at t equals 1, it is moving. What is it? Be very careful with the whole pronoun thing there. Particle y is moving left, and why? Because the velocity is negative. We good? What? Yeah, be careful about pronouns. You don't want to offend anybody with these right now. Actually, just be careful. It's not a nice thing to say anyway. All right. At t equals, so now we have at t equals 1, the velocity of particle x. So now we're looking at the other one. Is the velocity increasing or decreasing? So what do we have to decide if velocity is increasing or decreasing? Acceleration. And acceleration is the derivative of what? The velocity. And velocity is the derivative of? Position. The P word, position. Okay. So, and we're looking at particle x. This is particle x, right? So I want to find the velocity sub x of t. I find that by taking the derivative of the position, right? So this is 3t squared minus 6t plus 9. 12t? Oh, chutes and ladders, thank you. minus 12t plus 9. Okay, so I have v of t. Can I substitute 1 in? No, because what do I need? Acceleration. So I need a sub x of t. That's the derivative of the velocity. So this is going to be 6t minus 12. Yeah, that's all the second derivative is. And if I'd want the third derivative, the answer would be 6. Right? Just kind of the way that works. Okay, we okay so far? Everybody got that? All right, so now I need to know at t equals 1. So I'm going to take a sub x of 1. That's going to be equal to 6 minus 12, which is negative 6. So the acceleration is negative. What does that tell you about velocity? It's decreasing. So we answer our question by saying at t equals 1. Okay. That's my when. My what is particle x. Wait, so the velocity, sorry, the velocity of particle x. The velocity of particle x is doing what? Decreasing. Why? Because what's negative? Acceleration. Because acceleration, I don't know if it has two L's in there or not, acceleration is negative. Another way you could do this, instead of writing out the word acceleration, right here, we could say a sub x of t, or a sub x of 1 is negative. Or you can write out acceleration, because you've already stated what it is. But all right, are we good? I'm looking to see if I did spell acceleration right. Look at me. Okay, so now I want the displacement. So what did it say about displacement on that other page? It is, right here. Displacement is position 2 minus position 1. So it's your stopping point minus your starting point. Am I boring you, Devin? How do we find the stopping point? When do we start? At 0. At what is 0 when we start?
Oh, but you just plug in 5.
Plug in 5, because that's time. So that's the ending time. What's the starting time? 0. So we have to find both of those, then we subtract them. Okay? So, and this says of particle y. So that means I need, and this is just position, I'm not taking a derivative, y of 5 equals, so this is going to be the cosine of pi times, sorry, I was looking back at my notes because I felt like this didn't look familiar, but I did do this, which is equal to the cosine of 25 pi over 4. Is that a value you should be able to calculate? Yes, it is. Look what happens here. This is 0, this is 2 pi, right? Remember I said we think in fourths. So if this is 2 pi, that's also 8 fourths, right? Does that make sense? So every 2 pi is another 8 fourths. So I'm here, I go 8 fourths, 16 fourths, 24 fourths. So 25 fourths is right here. So the cosine of pi fourths is the square root of 2 over 2. Exactly. So now I also need to find y of 0. So that's going to be the cosine of pi times 0 squared over 4, which is the cosine of 0, which is what? 1. What do I do with these two things? Subtract. How do I know which order to subtract in? It is the ending position minus the starting position. So 5 comes after 0, so the 5-second position is the first one. So I can just say that the displacement, let me just say it's just the square root of 2 over 2 minus 1. You don't have to have any explanation. There's your answer. No, You don't have to. I would say just don't. What questions we got? All right. So number 4 is particle X moving away or towards the origin at t equals 2 seconds. So what do you think we need to find here? Away or towards. So does maybe directionality matter, right? If I'm going away or towards something, I'm either going left or right if I'm on there. So what gives me the left or right? Velocity. Okay. And we find velocity by do we already have the velocity function for x? Yeah, look back at number 2. Another reason why it helps for you to actually label things and be able to read your own work. Because v of x we already found, or I'm sorry, v sub x of t is 3t squared minus 12t plus 9. So I want to know what the velocity is at 2 seconds, so v sub x of 2 is equal to 3 times 2 squared minus 12 times 2 plus 9. So this is going to be 12 minus 24 plus 9, negative 3. We agree with that? So is it moving towards or away from the origin? Let's think about this. It depends on where it is, right? If it's over here, I know it's moving to, this means it's moving to the left, right? So if it's over here, I'm moving towards the origin. If it's over here, it's moving away from the origin. So besides velocity, what else do we need to know? Position. And so I need to find x of 2. So I don't have to scroll up at this. And this is going to give me 2 cubed minus 6 times 2 squared plus 9 times 2 plus 11. So that's going to be 8 minus 24 plus 18 plus 11, I think. Do I have this written down? I do. And so, is that 13? Positive 13? Everybody with me so far? Okay. So what this means then, my position, I'm over here somewhere at 13 because it's positive, so I'm over here. And then my velocity is negative, so I'm moving to the left. So am I moving towards or away from the origin? Towards. Okay, so I can say at t equals 2, particle x is moving toward the origin because x of 2 is greater than 0. That's another way to say positive, right? And v sub x of 2 is less than 0. So that's another way I could say that is that the position is positive and the velocity is negative. And that's just saying that with that little less words. You can use some symbols. It's okay. So do you see how to read the question? Ask yourself what you need. And if after you get what you thought you needed and then you're like, wait, I need something else, figure out what else you need and think yourself through it. Don't rush. Make sure you can read your work because you might need what you already found. You don't have to find it again. Okay? All right, so we want to know on what intervals is particle x slowing down. Right? So look back at your paper. What is talking about slowing down and speeding up? What would I have to know? I'm sorry? I still didn't hear what you said. Speed. Did you say magnitude? Okay. I'm sorry, my brain was not processing whatever you were saying. I don't know. So yes, I need to know the magnitude, right? But look at what it says under speed. The very last bullet says speed is decreasing. That's what we're looking for, right? When the velocity and the acceleration are going in opposite directions. So yeah, I need both. I need the velocity and acceleration. I don't have a time at which I need them, but I need to know when are the signs of those two things opposite. So did I already find the velocity and acceleration for particle x? I did. I found it up there in number 2, right? So my velocity sub x of t is equal to, I'm going to rewrite these, 3t squared minus 12t plus 9. And then my acceleration is 6t minus 12. So if what you are looking for is the function positive or negative, and you don't have just like a t equals 2 or something like that, this is when we want to do the sign charts. In order to get to the sign chart, I have to actually factor these. Okay, sign charts are easy. I can factor out a GCF here, so I get a 3, and then that leaves me with t squared minus 4t plus 3. Then I factor some more. I get 3, factor this, and that gives me t minus 1 and t minus 3. Okay, that's v sub x of t. My acceleration, a sub x of t, is going to be equal to 6 times t minus 2. Okay. So once you've got them factored, we're going to go back and, do y'all remember doing the sign charts? Kind of, sort of. Do you need a quick review on that? Quick review? Okay. So I'm going to do I was just thinking, I'm going to do a quick review by just showing you what we just did in pre-cal, and I think I want to, let's see. I'll just show you those notes. I can talk you through them. We'll do the polynomial sign charts, because that's really what we have as polynomials here. Oh, goodness. What the heck is going on here? All right. And then, this stupid board. Oh, no. I might have to go back to my... Okay, I've got to go back to my desk. Sorry. These things, they're easy. They are easy. I can just make my board do what I want it to do. These are easy. You had to know how to factor, though. That might have been your issue. Ooh. Okay. Okay, here we go. So, let's look at this. We have it factored, okay? So look at what's happening here. You can ignore kind of the inequality part of this because we'll get to that. Maybe I should do a different one. All we care about is, here we go. All right, so we factored it, right? Then we put these numbers on our number line, okay? Then we have to choose, so we know at these points the function value is 0 because these are my zeros. You with me? So then I need to know between the zeros is the function positive or negative. So I pick a number between the two. So I'm going to pick a number between negative infinity and negative 5. That'll be like negative 6. So when I multiply negative 6 in here, that's negative. And multiply. When I substitute, this is negative, negative 6 in here will be negative, negative, negative. So I have 4 negatives multiplied together. That makes it positive overall. If I substitute in negative 2, that's going to give me negative, negative, positive, negative. Odd number of negatives means it's negative overall. Okay, do you remember doing that? That sound familiar? Okay. Well, it doesn't matter if you didn't like it. You got to do it. Your opinion, unfortunately, it doesn't matter. Okay, so here we go. We have this. So now we're going to take these zeros and we're going to put them on this number line. But instead of writing out all our little negatives like we did last year, like we'd write out 4 of them and know that it's going to be positive, we got to do more on here, so we got to be able to think through it, which you'll be fine. So I'm going to put 3 numbers on here. And then from least to greatest, And so my numbers, my zeros here are just 1, 2, and 3. So 1, 2, 3. It's okay if it's not to scale, but it's not okay if they're not in order. Okay. We're going to do velocity in the numerator and numerator. Velocity on top, acceleration underneath. Numerator and denominator. All right, so let's pick a number less than 1. Let's pick 0. So I'm going to do the velocity. I'm going to do all the velocities first. So when I substitute 0 in here, this is negative times negative, which would be positive. Make sense? I substituted a number between 1 and 2, like 1.5. This would be positive. This would be negative. That means it's negative overall. Okay. Pick something between 2 and 3, like 2.5. This would be positive times negative, which is negative. Substitute something more than 3, like 4, would make it positive. Okay? We all good? Okay. Then I'm going to look at the acceleration function. There's only one and one factor, so it kind of makes it easy. I substituted 0, that gives me a negative. If I substitute 1.5 in here, I get a negative. I substitute 2.5 in here, I get a positive. 3.5 in here, I get a positive. Okay. So after doing all that, we have to remind ourselves what the heck we're even looking for. It says it's slowing down, so what has to be true about the signs? They have to be the opposite. If it's speeding up, they're the same. So whether it said speeding up or slowing down, our process up to this point would be exactly the same. But what we're looking for here, excuse me, is when the signs are different. Signs are different here, and the signs are different here between velocity and acceleration. Okay? Which means when we go to answer our question, we are going to say, let's see, on what intervals is particle x slowing down? So particle x, remember, don't just say it. Particle x is slowing down all right, so it's everything less than 1, right, from negative infinity to 1. So I can say for t is less than 1 and t is between 2 and 3. Does that make sense? Do you understand where I got that from? T is less than 1 and t is between 2 and 3. No, because that's answering it. I also have to justify it. How do we know this? Signs are opposite. So we say because signs for v sub x of t. Yeah, I can write velocity and acceleration if you want. A sub x of t are opposite. So you have to mention the signs. You have to mention how you know. You know because the signs are opposite. Okay? What questions you got? Okay. Your brain's hurt? Do you want to stop here for today? Too much? Okay. We can do that. We can do that. I was going to finish these too, but I don't want to shove it down your throat. But you got to, yeah. I hope they're watching the videos tonight.